Okay, this is going to be the second video of how Mrs. Bruno makes a review for a test. Now, keep in mind, this is not exact science and you should do your own type of numbers, but this is the type of thing we're looking at. We're going to start here at number 12. Okay, so given two functions, find a value such that f minus g of x equals 0. Okay, so it says given two functions, so let's give ourselves two functions. Let's say one of the functions is 2x plus 7. Just making it up. So you can make up your own or you can find a question if you want. Let's say that g of x equals 4x plus 1. So this is the same thing as f of x minus g of x, which would be 2x plus 7 minus parentheses, please be very careful, 4x plus 1. And we want that to equal 0. So clean up. 2x plus 7 minus 4x minus 1 equals 0. Negative 2x plus 6 equals 0. Subtract. Negative 2x is negative 6, and I'm out of space. Divide by negative 2, and x equals 3. Now, keep in mind, I just made that up. I don't know. I'm not looking at the test. There's a possibility that one of these could be like an x squared. Like, what if it said x squared plus a number, So make sure you're trying various things. All of these questions did come off of quizzes. So if you saw something similar, keep that in mind as you do this. I don't know if I can pause it enough. Hey, what's up, Mike? Do you see it there? If it's in the basket, take it. Well, then that won't help. See if you can find it. Okay, number 13. Given two functions, find f of g of x and g of f of x. This is all over the assignment I just gave you guys. F of g and g of f. And of course, I closed it up. Let's see if I can find it here. Okay, so let's see where are we at. Towards the end. Not that far, though. Okay, here's some right here. 21 is a good problem to do. 22 is a good problem to do. I did 21 in class, so I'm going to go ahead and do 22 right now. It's a little bit harder. So if f of x is 6x squared plus 4, g of x is 5x minus 2, the review said we're going to have to do f of g and g of f. So f of g of x. That means start at the innermost. So that's 5f, of 5x minus 2. This is the one I think kids will mess up. If you go to function f, you take out the x and you put in 5x minus 2 in parentheses. You're plugging that function into the other one. This here is where the kids make the mistake. They square that wrong. 5x minus 2, quantity squared is 5x minus 2 times 5x minus 2. So that's 25x squared minus 10x minus 10x. That's minus 20x plus 4. So that goes right here. 6 times 25x squared minus 20x plus 4 plus 4. Clean up, which means you're going to have to distribute. Don't mess that up. 150x squared minus 120x plus 24 plus 4. And to finish, we get 150x squared minus 120x plus 28. So that's f of g. Now, the good news when one of them is hard like that, the other one is usually significantly easier. When you do g of f, it will be easier. We're going to take g of f of x, which becomes g of 6x squared plus 4. And now we're going to function g, and we're going to take out the x and put in the 6x squared plus 4 minus 2. And this one, you don't have to do any fancy double distributing. You're just distributing 30x squared plus 20 minus 2, which is 30x squared plus 18. So that one is a little bit easier. Okay, so you have a bunch to try on that. You can look at that chart, but that was question 13. Given two functions, find the domain of their composition. Okay, so this is the domain of the composition. It's the only one. Domain questions are tricky. It won't hurt if you're struggling on this. Let's see if I can find one about a domain of a composition. Here's one. Okay, so let's look at 24. 24 wants the domain of f of g. Well, if you have f of g of x, that means g happens first, which is the square root of x, and it goes into function f, which is 5x plus 2. Now, what can I plug into this top machine? Well, I can't plug in negatives. So the only thing I can plug in is numbers greater than or equal to 0. How about this machine? Are there any problems here? No, that's it. So for f of g, the domain is x is greater than or equal to 0. Now you'll get something different if you look at g of f. For g of f, f happens first, and that's 5x plus 2. And then it goes into the square root of x. Nothing will break the top machine, but this machine has to be greater than or equal to 0 to plug in. But I don't plug into this machine. This guy plugs into that machine, which means 5x plus 2 has to be greater than or equal to 0. And that's tough. So you subtract 2, and you get 5x greater than or equal to negative 2. Divide by 5. X is greater than or equal to negative 2/5. Okay, don't hurt yourself, get upset trying to figure that out. If it seems tough, it's okay. The things you got to be on the lookout for are those square roots, because you can't have negatives, and then the 1 over. Like if I had 1 over 5x plus 2, then you would have to say that can't equal 0. Those are the two things you're looking for. But there's only one domain question on the quiz. You're going to be, or quest, whatever. You're going to be just fine if that causes you some problems. Okay, given two functions, find the value of the composition at a certain value, like f of g of 5 or g of f of 5. Again, we have quite a few of these to look at in that example I gave you. This time I'm looking for g of f of 5 or like numbers. Here's some. There's g of g. Let's look at this. Here's one exactly with 5. And I don't know that will be the case. I think you should look at some of these with negative numbers too. So let's look at 17. But all of these would be good. So f of g of negative 3. Start with the g of negative 3. Go to function g, take out the x, and put in that negative 3. That gives me 9 minus 2, which is 7. But that's just g of negative 3. So my new problem is f of 7. Go to function f, take out the x, and plug in the 7. 3 times 7 minus 1. 21 minus 1, so that's 20. Now you get something different if you do the other way. If you do g of f of negative 3, we start here at f of negative 3. So that would be 3 times negative 3 minus 1, which is negative 9 minus 1, or negative 10. So my new problem now is g of negative 10. Go to function g, take out the x, plug in that negative 10. When I square it, it will become positive. It's 100 minus 2, which is 98. Okay, so there's other practice problems like that you can do as you're looking at this list to make our review. How about 16? Oh, same thing. So you can do more practice with that. 17 is a composition word problem. Some of those showed up on your quiz, so make sure you look those up. I think there might be one on this document I have. Word problem, maybe not. Yeah, here's one. A stone is thrown into a pond, creating a circular ripple that spreads over the pond. So the radius is growing at 3 feet per second. So they want us to write a function for the radius in terms of time. So the radius is growing at a rate of 3 feet per second. That's a rate of change or a slope of 3t. There is no initial condition. How about area of a ripple? What's area of a circle? That's pi r squared. So they want us to find a of r of t. So they want me to take r of t, which is 3t, and plug it in to the r for this guy. So that will be pi times 3t squared. When you have a quantity squared, you square the 3 and you square the t. So that'll be 9 pi t squared. 9 pi t squared. Okay, what is the meaning of that function? Well, what that means is I can now figure out what the area will be based on the time. So it will give the square of the area, or just the area, in terms of time. So that's a composition word problem. There's also problems about discounts and coupons you can look up as well. Those might be good to look at. Okay, what do we know about even and odd functions? These two questions, or three for that matter, are just asking you what you know. Remember, even functions have y-axis symmetry. If you plug in negative x, you get exactly what you started with. And if you have a point xy, when you plug in a negative x, you get exactly what you started with, the y. Okay, how can you tell if a graph is even? It would have that y-axis symmetry. We looked at graphs that looked like, oh, that's so bad. But we looked at graphs that looked like this. That's still bad, but you get the idea. We looked at absolute value graphs, which is this is just garbage at this point. But they have y-axis symmetry. What did we know about the odd functions? Odd have origin symmetry, or 180 rotational is even better. When you plug in, oh, so sloppy, negative x, you get the opposite of the function, or change all the signs of the function. And if you have xy on a graph, if you change the x, you get the opposite of y. Those odd functions kind of looked like this. If you turn them upside down, they look the exact same. Okay? And then 21 and 22 want us to check if things are even, odd, or neither. We did those in the notes. Don't forget, we did those in the notes. It will look very much like the notes. Example, actually. Oh, that is actually the test right there. What do we got here? Let's see if I can find it. Some practice. Even, odd, or neither. There's some graphs for you to check. Here's one. They give you the graph, but let's pretend we did it algebra. Okay. Plug in the negative x. So I'll get 6 times negative x to the 5th plus 4 times negative x to the 3rd. Odd number of negatives, that'll be negative 6x to the 5th. Odd number of negatives, minus 4x to the 3rd. These are opposites. Both signs have changed, so this is odd. And if you look at the graph, you can really tell that it is odd. Okay, this 34 looks like it's even, and you can practice by showing with algebra to make sure you're understanding. 2 times negative x to the 8th plus 3 times negative x to the 6th. An even number of negative ones will just be positive, so that's 2x to the 8th. Even number of negative ones plus 3x to the 6th. That's exactly what I started with, which gives me an even. And again, you can look at the graph and tell that way as well. Okay, so that's kind of how I review the bottom half. I'll do another video. There is another video of the second half. I kind of did this in reverse order. But hopefully this will help you study a little bit. But don't just study this. Make sure you do your own problems too.